Welcome students to our video on area and perimeter, including the area of the rectangle, triangle, parallelogram, and trapezoid, and the area and circumference of a circle. Let's start with some definitions. The amount of space enclosed by a figure is what's called its area, the area of the figure. An area is measured in square units. Here's an example of a square unit. If I blew this up to be big enough where each side of this was 1 foot, this would be 1 square foot. If I blew it up so it was one inch on each side, it'd be 1 square inch. And I can make it a square centimeter, a square mile. I could make it a square light year for all it matters. It just has to be a unit of length. So the area, for example, if you look at this figure here, so the area of this figure is very easy to find. You just count the squares. You have square units. So in this case, this has an area of 7 square units. Perimeter is the distance around a closed figure, and that's measured in linear units. So that would be each individual unit as you go around the figure. So this figure has a perimeter of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 linear units. The distance around a circle is called the circumference of the circle. They don't use perimeter for circles, they use the word circumference. So we're going to be using formulas. And I want you to remember the way to use a formula. You do not have to copy this section. This is just a reminder on how to use a formula. Now we did already use a formula with the Pythagorean theorem. We had to write down a squared plus b squared equals c squared to start the problems there. So the first thing I do want to see you do is copy the formula onto your paper, because every one of these figures has a different formula. It's easier to have a template that you drop the numbers in underneath. You're going to find the necessary values from the given figure or information that you have for the problem, and then you're going to plug the numbers into the formula and calculate applying the correct order of operations. However, we already use the order of operations. This will include using exponents, doing operations inside parentheses sometimes, doing multiplication before addition, and so on and so forth. So let's start with a review concept, the area and perimeter of a rectangle. Let's start with area. The area of a rectangle is the product of the length and the width. So A equals LW, or L times W, with the length being one dimension of the rectangle and the width being the other dimension. Decide which is which before you start the problem. I'm going to call that one the width and that one the length. Write the formula. Plug in the numbers underneath the formula. Multiplying these together, I'm going to use my parentheses to show multiplication. And when I multiply those two numbers together, I get 112.2. But when I write my answer, it's 112.2 yards squared, or square yards. I can also write it 112.2 as QYD, like that. And then the area of this square. Again, length times width. So 18 times 18, which is 324. And that's going to be in square miles, or miles squared. Perimeter. The perimeter of a rectangle, this is the only one that has a formula on the formula sheet. Well, actually, I shouldn't say that. Square has a formula as well. We'll talk about that in a minute. But the perimeter of a rectangle is 2W and 2L. So 2W plus 2L. Or you could add the length and the width and then multiply by 2, which is the same thing as 2 times L plus 2 times W. So, if I look at this rectangle, same as the previous one, it is easiest to start off by writing down my formula and then plugging in the numbers. So 2 times, we'll call this one the length, 18.7, plus 2 times, we'll call this one the width, 2 times 6. 2 times 18.7 plus 2 times 6. Well, 2 times 6 is 12. 18.7 times 2, let's see, 18 times 2 is 36. 0.7 times 2 is 1.4, so 37.4. And then when you add the two of those together, you should get, I think it's 49.4. Yeah, that's right. Now this is not square yards, this is just yards, linear units, as if I'm drawing around the line, so 1 yard, 2 yards, etc., 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 all the way around. So it's a linear unit, not a square unit. We're not filling space, we're going around with perimeter. For this one, it's a square. Instead of 2L plus 2W, you can do 4 times a side, and that's on your Virginia SOL formula sheet. In this case, that's 4 times 18, so 72, and this is miles. So that's not 72 square miles, once more, that is just 72 miles, because it's a linear unit, not a square unit. We're, again, going around, not filling the space. All right? Triangles. The area A of a triangle in square units is A equals 1/2 BH, where B is the base of the triangle and H is the height. The base and height of a triangle must be perpendicular. Okay, so this symbol means is perpendicular to. This symbol right here means is makes a right angle with. They have to make a right angle, so we have to be able to see it. Whether it's inside the triangle, like this one, this height, the height of the triangle is also called the altitude of the triangle. Think height of a plane, for example. Okay, or your altitude or your height will be outside the triangle. If you have an obtuse triangle, you drop the height down and then draw the horizontal out with that bottom line as if it's sitting on the desk right there. So 1/2 times base times height. Now this works because a rectangle, oh, nope, wrong tool, hold on. A rectangle, or a triangle, excuse me, is half of a rectangle. Look at this shape here. If I fill in this space and I fill in this space, I could take this piece off, oh, rotate it, hey, that's something we've been doing. Actually, no, translate it and then stick it to this, and look, I'm going to get a second rectangle, a second triangle that's the same as this blue triangle. So a triangle is half of a rectangle, and that's where this formula comes from. So in this one, I'm going to have 1/2 B times H. That's 1/2. The base is 20. The height is 7.4. Both of these distances were given to you to be misleading, really. You don't need them. They're extraneous. You don't need them. Now you can do this in whatever order makes the best sense. I'm going to do 1/2 times 20 because that's easy. That's 10. So 1/2 times 20, that's 10. And multiplying by 10 is just moving a decimal point once. So 74, and it's square kilometers. All right, next triangle, 1/2 times base times height. So 1/2 times 2 times 4.7. And I know that looks a little strange probably because this is way out here, but this is still going to work. It is absolutely still going to work. It's just harder to see how that's a half a rectangle because you have all this weird empty space underneath it. 1/2 times 2 is 1. So 1 times 4.7, so we get 4.7 square yards. The parallelogram is just like the rectangle, except it's a little distorted. So it's the bent rectangle, but you still have the same area formula. Area equals base times height. The reason we call it a base instead is to make sure we understand and recognize that it's not a rectangle, but it's still the same concept as the rectangle. Look, if I was to take this piece off, and again, translate it over and tack it onto here, I get a rectangle. So it's the same concept. It's the same concept as I was just showing you with the triangles. So base times height, let's do it. Area equals base times height. In this one, remember, base and height, just like on the triangle, the base must be perpendicular to the height of the triangle. Must be. So in this one, that's 7 times the perpendicular side, 15.1. So 7 times 15.1. That's going to come out to be, and I did all of these ahead of time to make this go smoother, 105.7. And this one is a square unit because we did use an area formula. Okay, over here, area equals, this time they only give me the base and the height. So again, like with the triangle, I can, oh, I forgot to write my formula, BH. I can have that height, that altitude, which it's not really called an altitude on a parallelogram, only on a triangle. So I can have that height of the parallelogram, I can have that drawn on the outside or the inside, just like with the triangle. All right, 5.9 times 4, or 5 9/10 times 4 is 23 6/10. And that's going to be inches squared. All right. Trapezoid. I like trapezoids. They're cool looking. The formula is a little more complicated, though. Let's look at it. The area of the trapezoid equals half the product of the height, here, and the sum of the bases, B1, B2, the top and the bottom. So those parallel lines, those are the bases. So we add the bases, multiply by the height, then times 1/2. Or whatever order of operations makes the best sense mathematically in the problem. Now, first of all, why does this work? Well, I want you to think about 1/2 B1 plus B2. We found the average of the bases when we do that. Remember, to find the average of a group of numbers, you add them up, add those numbers up, and then divide by how many there were. So that would be 2. So I'm averaging the bases together. So if I think about it, averaged bases, like averaging the bases together, they'd be sort of probably about that size. And if I was able to take this and this little triangle here and break them up and put them, they would fit into the spaces. So I'm averaging the bases together to kind of get one length that gives the same area as a rectangle of a similar base and height. So let's use the formula. So 1/2 height times B1 plus B2. These numbers are called subscripts, just as a quick aside. They don't do anything mathematically. They're just labels. So instead of using A and B for like the two bases, they insist on using B1 and B2. I don't know who did that in the first place. Clearly it wasn't me because I disagree with them. I just think that's confusing. All right, 1/2. Now my height is 5.4. And then inside the parentheses, 7 plus 1.8. So the order of operations says that I do the inside of the parentheses first. So that's going to be 8.8. And then I can just type straight across my calculator, because let's be practical here. We're going to use a calculator. 1/2, or 0.5, times 5.4 times 8.8. And I should have, as a result for that, 23 76/100. How about this one? This one's pretty cool. Look, 1/2 times height times B1 plus B2. So 1/2, the height is 2. Oh, that's convenient. 1/2 times 2, that's my multiplicative inverse property. That's equal to 1. So 1 times 2 plus 4, or just 6, because 2 plus 4 is 6. Oh, going back, this is square kilometers, and this is square inches. And for the last two slides, we're going to talk about circles. So we are coming up pretty soon on Pi Day. We will do some activities for Pi Day. I will distribute a sheet of digits of pi for those of you who want to work on actually memorizing digits of pi, see how many you can memorize. But let's talk about circles. Well, pi is that glorious constant that I believe it was the Babylonians first figured out. You might have to help me out by Googling that. But it's approximately 3. But it's, if you take this formula right here, if you divide the circumference divided by the diameter of a circle, that ratio is what's equal to pi. So pi is actually, the definition of pi is the constant value you get when you divide the circumference of a circle by its diameter. Well, the glorious thing about it is it's impossible to do a measurement of the circumference and the diameter of any circle and actually divide and get pi, because pi is an irrational number, which means it can't be expressed as a fraction. I know, I think I just broke everybody's brain, but we'll talk about that some more in class. Now we're going to have the difference here with these problems between exact and approximate answers. Okay, so we're going to find exact answers, and then we're going to find approximate answers. All right, so what do I mean by that? Well, as soon as you put in use a pi button on your calculator, or put in 3.14 and substitute that for pi, you have immediately turned your answer into an approximation, because pi can't be given exactly. That's the nature of an irrational number. You can't give the value of pi exactly. It's just not possible because it's an irrational number. So what I want you to remember with this is if you leave the pi in the answer, your answer is exact. Let's find the exact circumference of this first circle. C equals 2 times pi times the radius. So the radius of the circle, remember, goes from the center out to the edge. And in this case, that's 2 times pi times 5, or 10 pi. That is my exact answer for the circumference of the circle. So what you do is you leave the pi in the answer. I know that sounds strange. For the approximate answer, we're going to actually put in our approximation for pi. I'll just write 3.14, but generally I tend to use a pi button on a calculator, which you have on your calculator at school, and then round off to the nearest tenth. Now either way, this is still going to be, in this case, 31.4 centimeters. Alright, so let's do this one. The exact value of the circumference of the circle, well, it's pi times diameter, or pi times the diameter of the circle. Remember, diameter goes all the way across through the center. Pi times 30.2, or 30.2 pi. That's an exact answer because that uses the constant pi and tells us we're multiplying, but it doesn't use the approximation for pi. Now let's approximate. So 3.14 times 30.2, and 3.14 times 30.2 does come out to be 94.9. Ooh, that's messy. And since we are finding circumference, these are linear units, not square units, 94.9. And this one is also centimeters. All right, last we have the circumference, the area of a circle. The area of a circle in square units is found by using the formula area equals pi r squared, where r is the length of the radius. So I love, I've heard the joke many, many times, look, pi r squared. No, no, teacher, pi r round. So I'm going to take my first one, area equals pi times the radius squared, or pi times 5 squared. Order of operations tells me to use the exponent first, so that's 5 squared is 25. So pi times 25 is 25 pi. And that's our exact area. So we can do the same thing we did on the other page. Or I can plug in 3.14, and we get our approximate area, which for this one comes out to be 78.5. And both of these are in square meters. Why don't you pause it and try the last one yourself? Find the exact area and then find the approximate area. And I'm going to pause it and write it out as well. And to finish off the area of the second circle, well, the first thing I did is I realized, wait, I don't have the diameter. I don't have the radius, I only have the diameter. So that meant I had to take the radius and cut it in half first, then plug it in, square it, and there's my exact area, and then plug in my approximation for pi, or use my pi button on my calculator at school, 716.3 square centimeters. And that is it for area and perimeter. I will see you guys in class.